traffic. It's getting worse. 3 out of every 4 Australians live in the state capital cities, and we all want to get to work at the same time. But this is nothing compared to the transport crisis facing more densely populated nations. Conventional planes, trains and cars simply won't see us through future decades. So what will the transport of the future be like?
"30 years from now, oil reserves will have run dry, there'll be no fuel, the combustion engine will be dead, and the conventional car condemned to the scrap heap." A bleak future? Well, perhaps not. A new generation of vehicles could save us from this grim fate.
I like this car. It's very quiet. The response of the accelerator is very good.
This car drives like any other. Its top speed is 150 kilometers per hour, and it can travel some 450 kilometers before it needs to refuel. But when it comes to the engine, it has more in common with the space shuttle than its petrol-powered cousins. Ever since the car revolution took off with Henry Ford's production line, vehicles have relied on the internal combustion engine. As we start the 21st century, it's still at the heart of the car. The technology has been tweaked and stretched beyond recognition, but there is a limit beyond which this dirty, smoky machine cannot be taken. And when the fuel runs out, there'll be no place for the internal combustion engine to go. And that's where the Necker 4 comes in. It's the latest in a series of alternative power cars to be developed by Daimler Chrysler. It's an electric car, but unlike any that has been seen before. Until now, these cars have been weighed down with heavy batteries. They can manage only low speeds over short distances and need to be recharged for long periods. So Daimler Chrysler decided to take a different approach. What if the electricity was made on board the car itself? And what if it could be generated using the most abundant fuel of all, hydrogen?
We need here no fossil fuels. It means so long we have water energy, the sun is shining, we can produce the hydrogen. And in the same time, we don't pollute the environment.
The electricity is made inside a fuel cell, a box where hydrogen and oxygen are combined to make water. During the reaction, energy is released, electrical energy that can be harnessed to drive the car.
When you push the accelerator, the hydrogen goes through this tube into the gas channel, and it provides our fuel cell with hydrogen. From the other side, we supply the oxygen from the air, and we react it inside the fuel cell to electricity.
Fuel cells are simple, efficient and pollution-free. Powering them requires only hydrogen obtainable from water and oxygen from the air. Which is why one country with plentiful supplies of both is planning to convert its entire transport system to fuel cells. High in the North Atlantic is the country of Iceland. A clue to why they're thinking so radically can be found on the farms of men like Olaf Eggersten. His farm has its own generator, the cowshed is air-conditioned, feed is dried, and there's even a hothouse where he can grow Mediterranean fruits. And the energy to do this costs next to nothing.
Og þessi jörð hefur þessi hlunnindi og það bara spurningin að nýta þessa auðlind.
Iceland sits on the point where the continental plates of Europe and America meet, creating a geothermal hotspot. Steam and water bubble out of the earth, providing both heat and energy to drive turbines. Elsewhere, there are abundant waterfalls from melting glaciers, providing non-stop hydroelectric power. Iceland already generates 2/3 of its domestic power from these waterfalls and geysers, yet this uses just 1% of the country's natural resources. So, these two men, Hjalmar Arnason and Bjorn Skulason, plan to tap this energy source further and produce hydrogen from water, taking Iceland, and perhaps the rest of the world, out of the carbon economy completely.
With respect to all the sustainable energy we have here around us and the manpower we have in Iceland, I believe that Iceland will become the first hydrogen society in the world.
Arnason is a member of Parliament and a visionary, and he heads a committee that is dedicated to making his dream a reality. He and Skulason have set up a company to draw up the blueprint for Iceland's future, and perhaps the future for the rest of the world. And they've been captivated by the NECA project's success.
The changes with fuel cells could be, to begin with, the buses and the such vehicles. Then you have passenger cars developing, and hopefully the automakers will be mass producing fuel cell vehicles in 2004 or 2005. Hopefully, shortly after that, we will have mass production of ships which could be powered by fuel cells. In the long run, we could also power airplanes with fuel cells or with hydrogen, since already all space shuttles and so on are powered by hydrogen.
To fuel this ambitious plan, Iceland is going to need to produce hydrogen on a large scale. But with nearly unlimited geothermal and hydroelectric power to hand, it'll be in a position to manufacture the gas cheaply and in bulk. And that's not all.
What is more, we see that within not many years, we might start exporting, and we will pretty soon, start exporting hydrogen from Iceland to the international market and obviously make money. Perhaps we will end like Kuwait of the North. That is our future dream.
Within 20 years, every car, truck and bus in Iceland will run on a hydrogen-powered fuel cell. And it may not be too many more years after that before we're all driving cars with fuel cells instead of engines and Icelandic hydrogen in place of Middle Eastern oil.
Hydrogen-powered cars may not be the only new way to get around. The old-fashioned tram has been reborn into an efficient people mover, like this new light rail system in Sydney. But in Japan, the concept of the train has gone even further, and Japanese scientists are looking to a natural phenomenon to power the high-speed train of the future.
It is one of the four fundamental forces of nature, generated by molten metal at the core of the Earth. And now it's being used to push a train along a track. That force is magnetism. These giant magnets power the fastest train in the world. They're so strong that they have to be superconductive and cooled by hydrogen. They're coupled with magnets on the track, which attract and repulse to pull the train along. The result of all this high-tech engineering is a train that could travel from London to Paris in less than an hour.
はい、私どもはこのシステムを開発する場合にですね、時速500キロでこのシステムってのはまさにそうですね、例えば東京大阪っていうのは1時間で結ぶことができますから、もう完全にですね飛行機に勝つことができるということで、この鉄道を採用してくれるというふうに私どもは考えております。
If this sounds familiar, it's because it is. Magnetic trains have been around since the 1960s. The desire for high-speed intercity links pushed everyone to look for alternatives to the traditional rail system. A floating train seemed the answer. Using magnets to levitate the vehicle above the track removed friction, and the electromagnetic repulsion that drove the train forward was pollution-free and virtually noiseless. It may have been groundbreaking technology, but will it ever be promoted from test track to transport network? In 30 years of working with maglev, Professor Tony Eastman has closely followed its development.
Maglev has been around for a long time, but it's not yet really found application. I think the costs of it are such that people have been very hesitant to commit to an implementation.
In the meantime, maglev was still being tested, and tested, and tested, without ever making the leap to fee-paying customers.
The reason was cost. Maglev is exceptionally expensive, and the comparatively cheap traditional trains were becoming almost as fast.
High-speed rail systems have really closed the gap. They have now advanced to 300 kilometers per hour and can go to 320 or perhaps 350 kilometers per hour. I believe that high-speed rail is a more economical system, while not quite so fast. The increased costs that one has to pay for maglev are just not worth the reduction in trip time that such a system could offer.
Super-cooled, super-powered magnets may provide speed, but at a price. The technology was simply too expensive to be of practical use. But now, maglev may have found a new lease of life, not at 500 kilometers per hour, but at 50. Congestion and pollution plagues every modern city. Roads cannot cope with the numbers of cars and buses, and metros are oversubscribed. What our cities desperately need is a new high-tech public transport system.
Maglev also, I think, does have a lower speed application. Japanese company HSST has got, in my view, a technology which has got nice characteristics for urban applications. It's the type of system that could be used for downtown people movers to provide a linkage of downtown buildings.
It may not be as swanky as its big brother, but HSST works on exactly the same magnetic principles as its high-speed sibling. It turns out that all the characteristics developed for speed are also useful in an urban transport system. Gripping the track provides safety. Magnets are non-polluting, and magnetic force can even cope with the most extreme weather. And because it's slower, it doesn't need powerful and expensive magnets, but smaller ones that can be laid on the track for a fraction of the cost.
時速100キロまでの大変高速な都市交通システムとしても私ども開発をしてきたわけでございます。浮上して走りますので、全くと言っていいぐらい騒音がなくて、また振動も少ないシステムでございますので、大変都市に優しい公害の少ない交通システムとして HSST を3両編成の車両を走らすことになっておりまして、運転士がいない全く自動の運転でもってこれをオペレートすることになっております。もうこの計画が現実にもスタートしております。この他にそういったこともあって21世紀の交通システムの主要なものになるんじゃないかなというふうに期待しているんですが。
In 20 years' time, I think that low-speed maglev rail systems will be really providing urban people mover type systems.
With commuters in some parts of the world already spending up to 3 hours a day stuck in traffic, HSST could offer a unique solution to gridlock. What started as an expensive experiment may yet prove to be the answer to our urban transport problems.
However smart these ground transport solutions, they alone won't be enough to solve future transport problems. perhaps it's time to look to the skies. But today's aircraft won't be able to cope with the ever-increasing number of passengers and cargo, and the high-tech alternatives, the rocket ships and space planes we've been promised, are still firmly in the realms of science fiction.
Which is why some scientists believe we may already have the solution right under our noses, in the shape of a 100-year-old idea. The airship. Quiet, spacious, environmentally friendly, and able to carry hundreds of passengers or tons of cargo. A new era in giant airships is beginning back at the Zeppelin factory in Germany with the revolutionary LZ N07.
The flight test phase is over, so it means we know everything of the behavior of the ship, and also we improved, of course, certain parts of the ship, and we are ready for certification now.
Zeppelin have used space-age materials and state-of-the-art engineering to construct their lighter-than-air craft, which they predict will take the transport world by storm, just as airships like these did decades ago. Most of these early airships were rigid, with an elaborate internal skeleton of heavy metal beams. Their huge envelopes were filled with the lightest gas, hydrogen. But this design was fatally flawed. When the Hindenburg exploded into a fireball, it was the beginning of the end for the airship. As a result, today's airships, nicknamed blimps, have no practical use for transportation and are seldom more than floating billboards for advertising. Their simple structure is non-rigid, where only the internal pressure of the gas maintains the shape of the envelope. Zeppelin have pushed the boundaries of airship technology even further. Their new design is more than just a bag of gas, like a blimp, and lighter and more maneuverable than rigid airships. It combines the best of the past with the best of the present to create a revolutionary design for the future. Dr. Strata, Zeppelin's CEO, explains.
This is a totally new approach, of course. The old Zeppelin was a rigid structure. The disadvantage of this structure is, of course, the weight. And if you're going to the aviation, always weight is a critical parameter. And therefore, we looked for extreme lightweight design and construction. This is carbon fiber, and that's the lightest material. And that means most of the parts are used from this, or made by this material. And the rest, where we need another stiffness parameters, is made from very light aluminium, of course. Everything which is common in aviation and space industry. I ask always people visiting the company what's the estimation of the weight. And the estimation is 500 kilos, 700 kilos. In reality, it's 95 kilos. So that means you can see the differences.
The Zeppelin's revolutionary design isn't just light. Its new propulsion system gives it greater safety and maneuverability than ever achieved before.
We designed a new propulsion system. And you see propellers. And we have 3 engine groups on both sides and at the rear end. And these propellers are swiveling propellers. And that means we can start and land like a helicopter.
This increased maneuverability, together with a state-of-the-art cockpit, makes the once dangerous takeoff procedure now both safe and simple.
After we have the clearance from the tower, then we tell the cruise ship that we're ready to go off mast. And all these handles then at that time are forward here. And then as we're ready to take off, we lift the vectors and give power with these when the ship lifts almost vertically.
Zeppelin's new airship can transport 12 passengers at cruising speeds of 80 miles an hour. Future models could carry many more. But when it comes to solving future transport problems, Zeppelin's new passenger model is just the beginning.
The real challenge for the future is cargo transport. If the burden of moving goods and machinery around the world could be taken off the roads, it might make travelling for the rest of us much more bearable.
Could an airship, larger, sleeker and faster than ever before, be the answer? It seems so. Brand Air Force Base in the former East Germany, once home to Russian fighter aircraft during the Cold War, is now a centre of airship excellence. Here, engineers have plans to build the biggest and most ambitious airship yet. The cargo lifter will carry payloads of up to 160 tons. That's the weight of a jumbo jet.
The cargo lifter is the basic idea to combine an airship with a crane system. The major job they will do, they will transport heavy lift outsized goods. Just to give you a comparison, the size of the goods is about 50 meters long, 10 meters wide, 10 meters high. So this is a three-store building actually, what we can transport. So we are focusing on these heavy machinery parts out of the power plant industry, civil engineering industry, out of the oil industry. So we can transport high volume goods, what's not possible today.
The cargo lifter will be so big that a special purpose hangar has been designed to house the first two models and to serve as a production facility. It will be the largest hangar on Earth. But before the full-scale cargo lifter can be produced, a smaller prototype model must be put through its paces to see if the new technology will work. This is the 1/8 scale model of the cargo lifter, affectionately named Joey.
We are very satisfied with the flight tests we have done so far. Joey serves many important purposes for us in the development process and in the construction process of the cargo lifter, because it was a kind of rehearsal for us.
Joey's success has allowed the engineers to begin production of the full-scale model. These airships will provide an environmentally friendly, efficient and elegant way of ferrying vast cargoes around the world. Relieving the pressures on ground transportation could yet see the return of giant airships to our skies.
How would a conventional 21st century family cope without the trappings of modern science and technology? Find out 7:30 next Friday in part 1 of an entertaining and revealing new series, The 1900 House.
This is no ordinary bus. It's one of only a handful of vehicles in the world which use revolutionary fuel cell technology, a domestic version of the power storage systems which helped the Americans and the Russians conquer space. If buses like this model in Mannheim, Germany, come through rigorous trials, the world may well see for the first time mass-produced zero-emission vehicle engines. This prototype, being trialled by the Daimler Chrysler company, is a prototype known as the NEBUS, with the NE an acronym for New Electric. NE-buses and NE-cars being trialled in Germany use fuel cells and engine technology developed in Canada by Ballard Power Systems and DBB fuel cell engines. These two companies have joined forces in Vancouver, British Columbia, to produce the world's first potentially commercial fuel cell technology. Buses using fuel cell technology have been trialled on service routes in Vancouver and Chicago for the past year.
Every morning, we run 2 buses every morning for approximately 3 to 4 hours, as it is a prototype and developmental part of the trials. To date, for a prototypical and a developmental program, the buses run extremely well, and we're very happy with the performance of it. Considering that it is a prototype and it is a new technology, the number of breakdowns or problems we've had with it have been minimal.
Fuel cells are simple storehouses for electricity, and Water vapour is the only emission from the tailpipe if the fuel source, hydrogen, is supplied independently. If hydrogen were to be manufactured through an on-board system, then the emission would contain carbon dioxide. Let's find out how the fuel cell works.
A PEM, or proton exchange membrane fuel cell, is made of two plates sandwiched together with a plastic membrane, coated with catalyst. Hydrogen from methanol, natural gas, or petroleum, and oxygen from air are fed through channels in the plates. Hydrogen on one side, oxygen on the other. The hydrogen and oxygen want to be together. The shortest way is through the membrane. But only part of the hydrogen atom, the proton, can pass through the membrane. The other part, the electron, has to take the long way around through an external circuit, creating useful electricity. The oxygen side attracts the protons and the electrons that have traveled through the external circuit, generating the byproducts of water and heat. A fuel cell will operate continuously as long as hydrogen is supplied. By combining single cells, you make a fuel cell stack to produce the required amount of power. A fuel cell system consists of a fuel processor, air supply subsystem, cooling subsystem, and controls. Combining these subsystems with the fuel cell creates a complete power generating system. This system will provide electricity to power a vehicle, stationary power plant, or portable power products.
So far, public trials of the fuel cell under operational conditions on service routes in Vancouver have been embraced by the public.
The public has welcomed it. The very first day that we put the bus in service, we were inundated with calls as to where the bus was going. People still have requests to find out where the bus is going. They want to ride it. We have people from all over the world who will make phone calls when they're in town specifically to find out where it is so they can go ride it. The local population, of course, embraces it because here in Vancouver we have a natural bowl and we have a pollution problem, so it's well received and it's very enthusiastic.
3 fuel cell buses operated by British Columbia Transit use hydrogen manufactured in this small unit on site at its suburban depot. Another 3 prototypes using the same system operate on regular service routes in Chicago. Ballard Power Systems technicians are convinced they have achieved a technological breakthrough and that they are developing a genuine alternative to the internal combustion engine.
A fuel cell is much like a battery in that it converts energy to electricity electrochemically by an electrochemical reaction. But the key difference is that in a fuel cell, as long as you supply fuel, it continues to operate, unlike a battery which discharges and then needs to be recharged again. So it can produce power continuously.
Well, in 1983, when we actually started to work on this, one never would have believed that, 15, 16 years later, you're suddenly looking at the reality of this turning commercial. And in our world, what turning commercial means is putting buses, trucks, and of course the personal automobile onto the street. And we see this happening by 2004 on out. And once you get to kind of 2004, every year there'll be more and more and more. And the neat thing is that in my lifetime, finally, I will sit in traffic behind a bus that does not smell and does not make me angry because it's got this horrible, dirty black stuff coming out of it.
Fuel cell technology is gathering momentum in the United States. Ballard has just announced a joint venture between Daimler Chrysler, the Ford Motor Company, and fuel providers Shell, Arco, and Texaco. Under the arrangement, the state of California is to test 30 fuel cell cars and 25 buses under operating conditions between 2000 and 2003. This experiment will provide crucial information on fuel infrastructure for the new technology. The Western Australian government continues to explore options efforts to secure a deal which will see Perth become the first Southern Hemisphere centre to conduct in-service bus trials using fuel cell technology.
And now Daimler Chrysler has brought NEBUS to Australia.
Lisa Miller. To those of us with a purely personal interest in wine, the chief contributor to air pollution in the big cities. With growing concerns about global warming and diminishing supplies of fossil fuels, even some key people in the industry acknowledge that the days of the petrol-powered car may be numbered. Car companies worldwide are pouring many millions of dollars into developing the ultimate green vehicle, and perhaps even more importantly, making it affordable. Now, the first petrol-electric hybrid car has hit the streets in Australia and is viewed as a big step on the way to the zero-emission vehicle. Tracy Bowden reports.
It looks new, it looks modern, but if this car pulled up next to you at the traffic lights, there's nothing to reveal it's also revolutionary. Honda's Insight is the first petrol-electric hybrid car on the market in Australia. Dr. Peter Saxon-Williams, the first to buy one.
Well, it's fun, certainly. Gimmick, I don't think it is. I think it really represents the first of a whole new technology. And also, I think there's a certain challenge to take part in that new technology.
As the name suggests, the hybrid is a blend of two power sources, a combustion engine and an electric motor, which provides extra power when needed. The motor also generates and stores surplus energy. What would you say is the main difference between driving a standard car and this car?
Well, for a start, it's very quiet. And every time you come to a halt at the lights, the engine cuts out. But apart from simple things like that, it's probably more similar to a car than it is dissimilar.
With the transport industry responsible for 16% of Australia's greenhouse gas emissions and fossil fuel set to become more costly before it eventually runs out, the race is on to develop the car of the future.
Every litre of petrol that's burnt puts out about 2.4 kilograms of carbon dioxide into the atmosphere. So if you can reduce fuel consumption of cars, and that's what hybrid does, you get a really useful reduction in greenhouse gas emission.
The Insight only uses about a third of the fuel of conventional cars, but the savings come at a cost. For a small two-seater, you're paying close to $50,000.
If you could bring hybrid technology to market for a reasonable premium over conventional petrol engine technology, you're going to sell a lot of them.
Last year, during the lead-up to the Olympics, Holden unveiled the all-Australian e-Commodore, the result of a multi-million-dollar joint project with the CSIRO. Technology developed for this concept vehicle will be used in upcoming standard Commodore models.
We're competing with everybody. I mean, there's every car company in the world has research programs for hybrid electric cars. Some of them take a different approach. We've gone for what we believe is the low-cost approach, using some good Australian ingenuity.
The CSIRO's Automotive Technology Centre in Melbourne, headed by David Lamb, also developed the Access hybrid vehicle.
We've got an automotive industry, components industry, quite capable of producing everything in this car. So there's nothing to stop us producing such a thing soon. But our real expectation is that we will either sell the components overseas, which is one of the reasons why we built the car, and also we'll license the technologies.
Already, Honda's Insight and Toyota's Prius, to be released here towards the end of the year, are selling well in the US and Japan. Toyota has sold 50,000 Prius worldwide. In Australia, Honda expects to sell about 60 Insights this year.
The other factor that's going to bear on the rate at which hybrids achieve any sort of success is government decisions. Okay, it's going to be possible for the federal government, for example, if they choose, to provide a break for hybrid cars in terms of a lower import duty. State governments could provide a break for hybrid car owners by offering cheaper registration fees.
The position of the government is we encourage fuel efficiency, we encourage the take-up of alternative fuels. We think that's in the national interest, both for environmental reasons and in terms of costing the consumer less.
While backing the CSIRO research, the federal government doesn't plan any tax breaks for those who try the new green machines.
Well, we can't afford it, basically, and it would be a short-term artificial stimulation. The real price, they're about, about 20%, 10% to 20% higher than the equivalent vehicle. That price will come down, as I said, when the mass markets develop, and they'll be the international markets.
But the fact is, hybrid cars are almost certainly an interim step, with companies around the world already trialling the ultimate green car, fueled by hydrogen.
Mixture of hydrogen and oxygen, you produce electrical energy, and the only byproduct is a little bit of heat and a little bit of water vapor. There is no carbon dioxide emission.
How far off are they?
Before a fuel cell is in the ordinary bread and butter car, I would say more than 20 years.
In the meantime, there are a lot of technical questions that have got to be settled. How is the hydrogen going to be delivered? Is it going to be stored in tanks as a gas? Are they going to freeze it to make it liquid, which leads to, significant handling difficulties? Are they going to sort of sell it as a liquid in the form of, say, methanol, and then use some sort of onboard chemistry set on each car to strip the hydrogen out of the methanol? What are they going to do? Those decisions all have to be made sometime in the next decade.
For now, Dr. Peter Saxon-Williams is very happy with the performance of his hybrid car.
It's done everything that the manufacturer said it would do, and it's certainly extremely economical. It's very quiet. It keeps up with the traffic.
But Peter, does it satisfy the rev head in you?
In a different sense. It's, I think, no, you can't accelerate and beat cars at the traffic lights, but certainly you get a great deal of satisfaction out of realising that you're not consuming huge amounts of fuel and you're doing it for half the price that somebody else is doing it for.
And there is more to life than dragging somebody else off at the lights. Tracy forced to ground a major part.